You're at a party, the host has mixed up the drinks, you've got Sprite and water, ammonia and baking soda, and you've got to identify them using universal indicator and vinegar. Before you serve the guests, and you can see they're all colourless liquids. Describe the observations you'd expect to see when the following liquids is tested with universal indicator and with an acid, the vinegar. And I've written the results here. Water is neutral, so it goes green with the universal indicator. We'll ignore the vinegar column for a second. Sprite contains an acid, is acidic, so it goes red with the universal indicator. Ammonia and baking soda are both basic, so they go blue or green, dark blue or bluish green with the universal indicator. You wouldn't be expected to know which is which here. The vinegar doesn't react with any of them apart from the baking soda, which contains a carbonate, so it releases carbon dioxide gas, which fizzes. Explain how you use your observations above. Okay, so you've done pretty much the hard work there. Now you've got to explain it. Okay, we add universal indicator. The Sprite, which is an acid, goes red. The water, which is neutral, goes green. And you can see these wonderful becauses, so you're linking things. These two drinks can be immediately identified. Universal indicator will turn bluish in the baking soda and ammonia. Bluish, green, blue-green, something like that. Hard to tell which is which. However, when we add vinegar to the baking soda, because vinegar is an acid and the baking soda contains carbonate, it will fizz. The baking soda solution will fizz because carbon dioxide gas is released, and ammonia will not fizz. So now you can tell the difference between the two of them. You're going to add you're going to start with some sodium hydroxide, add some universal indicator, and add sulfuric acid you found in the garage. Write a word equation and a balanced symbol equation. Well, sulfuric acid, that's obviously an acid. Sodium hydroxide, that's a base. Anything hydroxide's a base. Sodium sulfate is a salt, and water, well, that's just water. How do we figure out that the salt is sodium sulfate? Well, the metal, sodium, becomes the metal, the first part of the salt, and the sulfuric acid becomes the second part, but it changes its ending a little bit to sulfate. And the water is what's left. Okay, so now we've done the word equation, now the symbol equation. Either we know that sulfuric acid is H2SO4, or we go, oh, acids all contain hydrogen. So hydrogen is H+, sulfate is 2-. Swap and drop, the 2 goes there, the 1 goes there, and so I end up with H2. I end up with H2SO4. Sodium hydroxide. Sodium ions are 1+, hydroxide ions are 1-. They balance, so I get NaOH. Sodium ions are 1+, sulfate ions are 2-. So we swap and drop, the 2 goes there and the 1 goes here, so I get Na2SO4, and hopefully everybody knows that the formula for water is H2O. Okay, but the balanced part, what have we got to do there? What we have to do is we have to do a tally. We have to count the number of atoms on each side and make sure they're equal. So hydrogen has 1, 2 in the H2SO4 and another one in the NaOH. Sulfur only has 1, Oxygen has 4 in the H2SO4, 1, 2, 3, 4, and 1 more in the sodium, in the hydroxide. So that makes 5. And sodium, well, there's just one of those. So that's everything on the left-hand side. On the right-hand side, we do the same thing. Hydrogen, there's 2 in the water. 2. Sulfur, there's 1 in the SO4. Oxygen, there is 4 in the SO4. 1, 2, 3, 4. And 1 more in the water. 5. And Na, there's 2 of those. And now we need to make sure both sides are the same. Well, the sulfur's the same. The oxygen's the same. 1 sodium here, 2 sodiums here. And we balance equations by putting fat numbers out front. So if we put a fat 2 in front of the NaOH, we get 1 more sodium, 1 more oxygen, 1 more hydrogen. What have we got now? Now we've obviously balanced the sodiums. The oxygens aren't balanced, and the hydrogens have 4 on the left-hand side and 2 on the right. So if we put a fat 2 on the water over here, we have 2 more hydrogens, and we have 1 more water. So that means this is now balanced. 4 hydrogens on the left, 4 hydrogens on the right, 1 sulfur on the left, 1 sulfur on the right, 6 oxygens on the left, 6 oxygens on the right, 2 hydrogens on the left, 2 sodiums on the left, 2 sodiums on the right. What's going to happen to the changes in color that I would observe while adding the acid? Okay, well, it's a neutralization reaction because the acid neutralizes the base to form 2 neutral products, water and the sodium sulfate. Describe the color changes in color and pH as the acid's added. Explain the type of reaction. Explain the relative amounts of hydrogen and hydroxide ions. Relative doesn't mean you have to come up with numbers. It means you have to say, oh, there's more of this than this, or they're about the same, or there's heaps more of this than this. When universal indicator is first added to the bleach, the color is dark blue, or you might even say purple if you weren't sure, with a pH of approximately 12. You might not know that it was 12, and you might guess that it was 11 or 13, and that would be fine. This means there are mostly hydroxide, mostly OH- ions rather than H+ ions. After adding a small volume of acid, the color will change towards a lighter blue dark green with a pH of approximately 8 or 9. So because we're adding H+ ions, it's becoming more acidic, it's heading towards neutral, so the pH is dropping. There are still more OH- ions than H+ ions, but the difference isn't as big as it was. Adding more acid will turn the solution green, at which point the solution's neutral, and the concentration or number of OH- hydroxide ions equals the number or concentration of H+ ions, and I've made water. So the pH is 7. As I keep adding more acid, the solution will become acid, and it will turn yellow and then orange, indicating a pH of 4 to 6 with more H+ than OH- ions. And if we keep adding acid, the color will eventually become reddish with a low pH of 1 to 2, indicating that the H+ ions are dominating and only a few OH- ions are in solution.